The real numbers, a set of numbers so incredibly important to life as we know it, yet its rigorous definition is not what you'd think. It's the ordered field containing the rationals satisfying the condition that all non-empty subsets that are bounded above have a least upper bound. Doesn't it seem easier to explain than that? Well, yeah. Explaining it to an average person takes a couple seconds. It's all the numbers on the number line. Surprisingly enough, though, mathematicians were fine with intuitive definitions until the late 19th century, which goes against everything we're taught in mathematics today. Through history, it becomes apparent that the concept of real numbers evolves from the categorization of the relations between rational and irrational numbers. Sometime around 750 to 650 BCE, we see the first instance of irrational numbers in Indian mathematics, and by 500 BCE, the importance of irrational numbers becomes increasingly clear with Pythagoras' mathematics and geometric-based mathematics of Greek mathematicians of the time. Around 300 BCE, the Greek mathematician Euclid published his collection of books entitled Elements, which provided a clear base for the fundamentals of mathematics we use today and played a crucial role in furthering mathematics into the Common Era. From the 5th to 15th century CE, we see the acceptance of some mathematical ideas, but we also see further development in the use of irrational numbers, as algebraic objects rather than measurements or geometric quantities, and as solutions to quadratic equations. By the 16th century, a mathematician by the name of Simon Stevin came up with the founding principles for decimal notation that are used today in his booklet De Tiende, or The Art of Tenths. He said that both rational and irrational numbers are similar in that they can both be represented as decimals. This provided a crucial gateway into how rationals and irrationals are similar. By the 17th century, we see the first instance of the term real to categorize numbers as separate from imaginary numbers, but it isn't until the 19th century that we begin to see the field of real numbers take form. The first categorizations and definitions of mathematical fields came about in the early 1800s, and with it came the ordered field. It is also during the 1800s that we see the development of modern-day set theory, and in 1871, we finally get a rigorous definition of the set of real numbers from George Cantor, though his work heavily relied on the advancements of Cauchy in the early 19th century, who came up with the notion of Cauchy sequences. From then, David Hilbert defined the real numbers as 18 different axioms, which today we recognize as the 16 axioms of an ordered field, the Archimedean property, and the completeness property. Finally, in the 20th century, we see the minor adjustments that gave us the definitions of real numbers that we see today.